question number 21. Let ABCD be a cyclic quadrilateral. Explain why the exterior angle at any vertex is equal to the interior opposite angle. So we have to take ABCD is a cyclic quadrilateral, and we have to explain why the exterior angle at any vertex is equal to interior opposite angles. ABCD is a cyclic quadrilateral. All the 4 points should be on the circle. Now we have to take one exterior angle. They ask us to check exterior angle. I'm just taking this point, okay? This angle, okay? ADE is an exterior angle. So according to the statement, we have to prove exterior angle at any vertex is equal to interior opposite angles. Okay, that means ADE, this angle, ADE should be equal to interior opposite angles. Okay, I have to prove these two angles are equal. So this is what I have to prove it. Okay, first we'll write the givens. Okay, given. So what is given? ABCD is a cyclic quadrilateral. If it's a cyclic quadrilateral, I can just say that sum of two opposite angles is equal to 180 degree. Yes, we are taking as this is a cyclic quadrilateral. I can just say that. So first, just take sum of two opposite angles. Angle ADC, okay, ADC plus angle ABC, okay, ABC is equal to 180 degree. That is supplementary. Sum of two opposite angles is equal to supplementary, okay, supplementary. Okay, now I can take this is first equation. Now you consider this, okay, this is forming a linear pair. EDC is a straight line. EDC is a straight line. And these two angles, okay, sum of two, okay, adjacent angle is equal to 180 degree, right? So linear pair. By using linear pair, I can just say, okay, as, I can just say as EDC, okay, form a straight line. Straight line, I'm going to use the linear pair. Angle ADE, okay, angle. So ADE plus angle ADC, okay, angle ADC, ADC is equal to 180 degree. So this is nothing but linear pair, okay. I'm just taking this equation number 2. Now you compare 1 and 2, both right hand sides are we are having 180, 180. If the right hand sides are equal, we can just equate left hand sides are equal. So from 1 and 2, from 1 and 2, okay, from 1 and 2, as right hand sides are equal, I am going to equate left hand side. So angle ADC plus angle ABC, okay, angle ABC should be equal to angle ADE plus angle ADC. Now here ADC, here also ADC. If I bring it to this side, it will get cancelled. Correct? So balance what you are getting? ABC. ABC is equal to ADE. So exterior angle is equal to interior opposite angle. So we got the proof. Okay, therefore I can say angle ABC is equal to angle ADE. Okay, hence proved. Okay, hence proved. Okay, you have to understand what has to be proven. Exterior angle is equal to interior opposite angle. So we have proven. So question number 22. There is no chords of circle that is longer than its diameter. How do you justify this statement? Okay. So there is no chords of a circle that is longer than its diameter. So we know that the diameter is the longest chord of the circle. So we have to give the justification for the statement. Okay. For that, okay, first of all, we have to take a triangle first. Okay, first you have to draw the diagram. Okay, I'm just taking a circle. Okay, I'm just taking a circle. Now I have to take a chord and I have to take the diameter. Okay, first of all, I'm just drawing the diameter. Okay, Now this is the diameter. I'm going to draw it first. Okay, so now this is my diameter. So diameter of the circle. Next, I have to take one chord and you have to prove that the longest chord is the diameter. So I'm going to take one chord. Okay, I'm just taking this as a chord. Okay, so I have to prove the longest chord is the diameter. Okay, for proving this, I'm going to mark this as a center. Okay, I'm just taking this as center. Okay, I'm just joining. Okay, so these 2 points and this point center to the this point. I'm just getting a triangle. Okay, I'm just getting a triangle. Hmm. So if you want to mark this as, okay, this is AB. I'm just marking this as, yeah, so AB. So I'm going to name this chord as AB. Okay, I'm just taking AB as a chord with a center O. Okay, and this is the diameter. So we have to prove that there is no chord of a circle is longer than its diameter. Actually, here OB and OA. Okay, that is OA is one of the radius and OB is one of the radius. Okay, so if you are considering AOB is a triangle, okay, we know the theorem. Okay, so we know the triangular inequality property. Okay, the inequality of triangle property, sum of, okay, sum of the length of any two side should be greater than the third side. Okay, that is the triangle inequality property. Okay, so now here I can just say OA is the radius, OB is the radius. According to the triangle inequality property, sum of the length of any two sides should be greater than the third side. R plus R should be greater than AB. So R plus R, that is R plus R is 2R. 2R is nothing but diameter. Okay, 2 times radius is diameter. So diameter is greater than the chord AB. So here is the proof. Okay, so now how we can give the proof? First, I am just taking let AB be any chord of a circle with the center O. Now join OA, OB. I am getting, okay, a triangle. In a triangle AOB, sum of any two sides is greater than the third side. That is triangle inequality property. Okay. So according to this property, I can just say sum of any two side of the triangle, that is R plus R, should be greater than the third side, that is AB. So R plus R is 2R. Okay, 2R is greater than AB. So 2 times radius, we know that that is diameter. Okay, D. Diameter is greater than AB. Okay, so therefore no chords of the circle can be longer than its diameter. Okay, so diameter will be the longer than any chords. So well, moving into the next question, question number 23. So question number 23, let A be any point within the given circle with center O. Show that the shortest chord of the circle that passes through the point A is the one that is perpendicular to the OA. Okay, so we have to take A be the point within the given circle with the center O. We have to show that, okay, the shortest chord of the circle that passes through the point A is the one that is perpendicular to OA. First of all, we'll go with the diagram. Okay, so the diagram. Okay, so I'm just taking a circle. Okay, with the point A be any point within the given circle. O is the center. So now I have to show that the shortest chord of the circle. Okay, if I consider, okay, this is shortest chord passing through the A is the one perpendicular to OA. This is the perpendicular, only one that is perpendicular to OA. And what do you have to prove? We have to prove that, okay, this is the shortest chord. I have to prove it. Okay, this red line is the shortest chord. For this, I can just give some name for this. Already A we have taken. Okay, now I'm just giving the name as B. So A, B, C. Okay, so BC is the shortest chord. I have to prove it. For proving BC is the shortest chord, I'm going to take one more chord. Okay, so I'm just taking this, considering this chord. So this is A, B, C. I can just take it as this is E. Okay, I'm just taking this is E, F, E, F. So what name you can give? Okay, A, B, C, D. Okay, we have to give it name as D. Okay, so A, B, C, and this is I can just give us okay a D. Okay, where's the line went? So I'm just considering this is one of the line. Hmm? So I can name this as so D, E. I'm just considering one more chord. Then only we can just compare which is the shorter one. Okay, either BC is the shorter one or D is the shorter one. Okay, for proving okay BC is shorter from OA, right? So I have to do the construction. Okay, I'm just making one line. Okay, this is OA is perpendicular to BC, it will form 90 degree. Hmm? The same as for DE, I'm going to make one more okay 90 degree line. Okay, I'm just marking O. Okay, this is a 90 degree line, this will form 90 degree. Okay, so I can just take this as M. Okay, I'm just naming this as M. So now, so actually what you have to prove this, okay, shortest, okay, BC is shorter than DE, we have to prove it. So we are going to use theorem number 8. Okay, we are just going to apply the theorem number 8 here. This theorem says if AB is greatest length, okay, if the length of AB is greater than DE, the distance from the center is less. If AB is greater, the distance from the center is less. If DE is smaller, the distance from the center is greater. So just reverse. If the length is greater, distance from the center is small. Okay. If the distance from the center is small, okay, the chord is greater. Okay, here we have to prove BC is shorter, we have to prove. We can just see here OA compared to OA and OM, OA is longer. Okay, distance from the center, this is longer. Therefore, BC is shorter. Here OM is shorter, therefore DE is greater. Hope you can understand. Okay, if shorter distance, the chord it will be longer. If it's a longer distance, the chord is shorter. So you can just easily prove, right? OA is the longer distance, therefore BC is the shortest chord. Okay, now this is the proof. Okay, so first I'm just let okay DE be any other chord through A. Okay, I'm just drawing OM. OM is perpendicular to DE. Since OM is perpendicular to O to the DE, okay, OM. Okay, OM it will be less than this distance, it will be less than OA. Okay, OM is less than OA. Then we can use the direct theorem number 8, or this is a shorter form of theorem number 8. The chord near to the center is longer. Okay, the chord nearest to the center is longer, which is the distance. If this is very near, the chord is longer. So therefore, here, which is so BC. Okay, BC is less than okay D. Okay, BC is okay here. This is distance is more. Therefore, BC is less than DE. So BC is the shortest chord of okay shortest chord passing through A. So 24th question. How would you use the following figure to justify the statement that the angle in a semicircle is 90 degree? Angle in a semicircle is 90 degree. That means here one angle is given A and B. So we have to prove angles in a semicircle is 90 degree. We have to prove it. So we already learned one theorem statement like angle subtended by an diameter is right angle. Angle subtended by an diameter is right angle. Or we can say angles in a semicircle is 90 degree. So we have to give the proof for this. So they itself given, okay, in a two triangle, they have divided into two triangles and two triangles here. Okay, so this length is equal to this length. I can just give the name as this is A means I'm just taking as this is B and this is C. I'm getting two triangles. One is AOB and AOC. In AOB, OAB is equal to OA. They itself they have given the marking. OA is equal to OB. That means two sides are equal in a triangle. I can say this is an isosceles triangle. AOB is an isosceles triangle. AOC is an isosceles triangle. If it's an isosceles triangle, we know that base angles are equal. This is A mean this is also angle A. And this is also isosceles triangle. Base B mean this is also B. Okay. Isosceles triangle base angles are equal. For proving this is 90 degree, I have to take the triangle ABC triangle and use the angle sum property of triangle. We get the proof. So now first I am going to consider in triangle OAB. Okay, in triangle OAB. Okay, proof. Justification or just take it as proof. Okay, proof in triangle. Okay, in triangle AOB. In a triangle AOB, they itself given OB is equal to OA. Okay, OA is equal to OB is given. So therefore, okay, triangle AOB is an isosceles triangle. AOB is an, okay, so isosceles triangle. If it's an isosceles triangle, base angles are equal. Okay, base angles are equal. Therefore, I can just take the triangle angle OAB. Okay, therefore, angle OAB is equal to angle A. I'm just taking this is A, mean this is also A. Okay, so now I'm just taking this as 1. Okay, now the same way similarly I can say triangle OAC also isosceles triangle. Okay, similarly I can just write, okay, similarly triangle OAC. Okay, OAC also isosceles triangle. OAC also isosceles triangle. Okay, isosceles triangle. Isosceles triangle base angles are equal. This is B mean this also B. Okay, therefore I can take angle OAC. Okay, angle OAC. OAC is equal to B. Okay, second. Now I'm going to consider a triangle ABC triangle. Okay, so in a big triangle, in a triangle ABC. Okay, so I'm going to consider. Okay, so in triangle ABC, so big triangle. So in triangle ABC, so use the angle sum property. Okay, in a triangle ABC, okay, angle sum property means angle A plus angle B plus angle C is equal to 180 degree. That is angle sum property. Angle sum property. Okay, so angle A, what is angle A? Angle A is dividing into two angles, right? So A plus B plus angle B is only angle A. Angle C is only B is equal to 180 degree. Now A plus A, that is 2A plus B that is 2B is equal to 180 degree. So we can just take 2 as a common. If I take 2 outside, A plus B is equal to 180 degree. Now take this 2 to this side. So A plus B is equal to 180 divided by 2. So 180 divided by 2 is 90 degree. That is A plus B. A plus B is equal to 90 degree. So A plus B, if I add these two, I am getting angle A. Okay. So therefore, angle A is equal to 90 degree I am getting. So angle A is nothing but angle in a semicircle. Okay, the angle in a semicircle is 90 degree. Okay, therefore angle in a semicircle is 90 degree. Okay, once again, we are just, as they have given two sides are equal, we can just say AOB and AOC is an isosceles triangle. If it's an isosceles triangle, base angles are equal. This is A mean this is A. This is B mean this is B. So just take, okay, a big triangle ABC, apply the angle sum property, we got the result. So next question is 25. We have to teach, right? So 25 is, right, a little different one. So compared to 24 and 26, okay, both are same concept. So I am just going to take 26 first. 25 is next. Okay. So I'm just going to complete 26 first. Next, I'll be doing 25th question. Okay. Now, 26th question. How would you use the following figure to justify the statement that the sum of the opposite angles of a cyclic quadrilateral is 180? So we know that sum of the opposite angles of a cyclic quadrilateral is 180. So we have to give the proof according to this given diagram. Okay. The same concept here, inside the square, we have a quadrilateral. This is a cyclic quadrilateral. Okay, we can just say A, B, C, D is a cyclic quadrilateral. So we have to prove sum of two opposite angles is equal to 180. We have to prove. Okay, they still given all the markings, right? So here, if you are just taking AOB, two sides are equal. So two sides are equal. AOB is an isosceles triangle. If it's an isosceles triangle, base angles are equal. This is B mean, this is also P. And this also isosceles triangle. Q mean, this is Q. This is U mean, this is U. So this is V mean, this is B. Base angles are equal. Okay. Next, if it's a quadrilateral, we are going to apply the concept of angle sum property of quadrilateral. Sum of all four interior angles of a quadrilateral is 360 degree. Okay, we get the proof. So in triangle, so AOB. Okay, in triangle AOB, two sides are given equal. Okay, which two sides are OA is equal to OB is given. So therefore, I can say, okay, triangle AOB is an isosceles triangle. Is an isosceles triangle. Okay, if it's an isosceles triangle, base angles are equal. I can just say that okay, OBA. Okay, angle OBA is equal to P. Okay, similarly, we can just say this triangle, this triangle, this triangle. All the triangles are isosceles triangle. Okay, similarly, I can just write, so similarly, okay, similarly, triangle, okay, OBC, triangle OCD, and triangle ODA or isosceles triangle or isosceles triangle. Okay. If it's an isosceles triangle, base angles are equal. This is Q, this is U, this is V. Okay. So therefore, in a triangle, okay, in a quadrilateral, okay, in quadrilateral, I am just going to take in quadrilateral, ABCD. Okay. In a quadrilateral ABCD, okay, I'm going to use the angle sum property of quadrilateral. A plus B plus C plus D is equal to 360 degree. Angle A plus angle B plus angle C plus angle D is equal to 360 degree. This is angle sum property of quadrilateral. Angle sum property. So angle A, how we can write? Angle A is splitted into P plus V. Okay, that is P plus V. Angle B is P plus Q. Angle C is Q plus U. Q plus U. Angle D is U plus V is equal to 360 degree. Okay, so everyone, 2 times P, 2 times V, 2 times Q, 2 times U. So everything I'm just getting 2 times. So 2P plus 2v plus 2q plus 2u is equal to 360 degree. So everywhere 2 is common. I can just take 2 outside. If I take 2 outside, p plus v plus q plus u is equal to 360 degree. Now take 2 to this side. So p plus v plus q plus u is equal to 360 divided by 2. 360 divided by 2 is I am getting as 180. Okay. That means so p plus v plus q plus u is equal to 180 degree. So actually we have to prove sum of the opposite angles of a cyclic quadrilateral is 180. So if you are taking P plus V, okay, P plus V. So we can just write it as angle A plus Q plus U, okay, Q plus U, that is angle C, is equal to 180 degree. So sum of two opposite angles in a cyclic quadrilateral is 180 degree. So hence proved, okay, hence proved. So as per the given condition, okay, all the four triangles are isosceles triangle. Isosceles triangle means base angles are equal, equate, and use the angle sum property of quadrilateral. So previous question, angle sum property of triangle. Here is angle sum property of quadrilateral. So question number 25, in a circle, two chords C dash and D dash are drawn perpendicular to a diameter AB. So prove that the segment M dash joining the midpoint of the chord CD and C dash D dash is perpendicular to AB. Okay. So first of all, you have to draw the diagram. Okay. So we'll draw the diagram first. So in a circle, okay, I'm just taking a circle. Okay. So in a circle, two chords C dash and D dash are drawn perpendicular to the diameter AB. First of all, I draw the diameter. Okay, I'm just drawing the diameter. This is the diameter. I have to draw two chords which is perpendicular to, okay, so AB. This is AB. I am going to draw two chords. One is, okay, this is one chord. Okay, I'm joining this. And one more chord. Okay, I'm taking, this is one more chord. Okay. So two chords that should be perpendicular to the diameter. Okay, it will form 90 degree, 90 degree. So I have to prove that M dash joining the midpoint of the chord CD and C dash D. Okay, which is CD. Actually, we have to name this as first. We'll just name it as. Okay, so actually this is the diameter. Okay, diameter AB. This is AB. Is the diameter. I'm just drawing two chords. One is C dash, and next one is D dash. So now prove that the segment M dash joining the midpoint of the chord CD. Okay, midpoint of chord C and D. Okay, then I have to join these two. Okay, midpoint, join this and join this. So now I have to find the midpoint. Okay, so if I find the midpoint, this is one midpoint and this is one midpoint. Prove that the segment M dash joining the midpoint of the chord CD and C dash D is perpendicular to AB. We have to prove it. Okay, so AB you have to prove it. Okay, so I'm going to join the midpoint of, okay, this is M dash. Okay, I'm going to join this M dash. Okay, M dash is a perpendicular to AB. We have to prove it. Okay, so we are going to prove it. So actually this is M, this point is M, this point is M dash. So to prove M dash is perpendicular to AB, it's form 90 degree, we have to prove it. Okay, this is what we have to prove it. Okay, Actually, according to the given question, C dash is perpendicular to AB. This is 90 degrees given in the question. And D dash, this also 90 degrees given in the question. So we have to prove M dash is forming 90 degree. Since it's given C dash is perpendicular to AB, that is forming 90 degree. D dash is also perpendicular. Okay, it's forming 90 degree. Okay, this is also 90 degree. So we can just say that C dash is parallel to D dash. This is 90, this is 90. Therefore, the distance will be, okay, we can just say these two are parallel. C dash is parallel to D dash. We can say as M dash are the midpoint of C, D and C dash D. Okay. Now the segment joining the midpoint is parallel to C dash. Okay. So M dash is parallel to C dash. Okay. In the beginning, C dash is parallel to D dash. Is joining the midpoint M dash. So M dash is parallel to C dash. Okay. Since C dash is perpendicular to AB, M dash is perpendicular to AB. So now this is perpendicular to AB. So M dash, okay, M dash is perpendicular to AB. Now this is 90 degree. As this is parallel means we can say this also 90 degree. Okay. So this also I can say 90 degree. So hence prove. So we have to prove M dash is perpendicular to AB. So we got the proof.
Thank you for watching. Kindly like, subscribe and share. Thank you.